Good afternoon, and welcome back. Bem-vindo de volta to our friends and colleagues in Brazil. My name is Gabrielle Canonico, and I am the Marine Life Program Manager with the United States Integrated Ocean Observing System, which is housed at the U.S. National Oceanic and Atmospheric Administration, or NOAA. It is my pleasure to be your moderator for the final day of this dialogue on ocean monitoring and research. Over the course of this 3-day dialogue, scientists and subject matter experts from Brazil's Ministry of Science, Technology and Innovation and from NOAA are exchanging information on ongoing initiatives and mutual interests related to ocean monitoring and research, including general efforts related to ocean observing, remote sensing, and in situ monitoring. On Wednesday, we focused on ocean monitoring and observation efforts in the Atlantic. Yesterday, we talked about oil and sargassum, and today we will look at the work our agencies are doing on ecosystems and biodiversity in the region. To kick off presentations today, we will first learn about the Brazilian Coast Monitoring System from Dr. Mauro Cirano from the Federal University of Rio de Janeiro.
Ali, can I have permission to present?
Yes.
Can you see full screen mode?
Yes.
Okay, excellent. Good afternoon, everyone. So I will be giving this presentation on behalf of Dr. Carlos Garcia. And SiMCosta is the acronym for the Brazilian Coastal Monitoring System. So the way that the program is structured, it has a national coordination who is done by Carlos Garcia. We have an operational manager who is Ella Pereira. We have various local coordinators. I am one of these coordinators, and we also have a technical team. And Fernando is one of the person in charge of SiMCosta here in Rio de Janeiro. So the way that SiMCosta was planned is based on a national coordination, which is done at FURG in Rio Grande do Sul state, and we also have local teams. And those are all the universities where we have equipment, and we also have the local teams. And in addition to all these universities along the Brazilian coastline, we also have INPE as one of the partners, and the Brazilian Institute of Geography and Statistics. So the main objective or the main goal of SiMCosta is to provide long-term and accurate essential climate variables along the Brazilian coastal zone. And as specific goals, we intend to provide continuous and free access to high-quality data. We develop tools and educational material to be used by educators and users, and we also intend to contribute to the Brazilian government to establish climate-related policies. What we can see here are the platforms involved in the project, and we have two kinds of platforms. In the left side, we have the moored buoys, and we have a set of different buoys. For instance, that one in the bottom left side of the image is the buoy that we use here in Rio de Janeiro. And it's important to mention that all the buoys are moored in shallow coastal waters with depths shallower than 20 meters. And on the right side, we have the tidal gauges, and all the tidal gauges are installed in ports or piers. So the variables observed within the SiMCosta program are related to the atmosphere, and we monitor precipitation, pressure, wind speed and direction, air humidity, solar radiation, temperature, and CO2 concentration. On the ocean side, we have two different groups of variables. The first one is related to the biogeochemical parameters that include turbidity, fluorescence, dissolved nitrate concentration, dissolved O2, total pH, and in addition, we have surface salinity, sea surface temperature, currents, waves, and sea level as well. It's important to mention that not all the buoys monitor all the variables that are listed here. For instance, the buoy here in Rio de Janeiro only monitors the variables at the end of this table, and we are including this for the next year the turbidity and fluorescence as well. So the main idea or the main goal is to monitor all these variables, but at the moment not all the buoys do that. Regarding the deployment of the SiMCosta buoys, I can say that we use different rules and vessels as well, and those pictures can illustrate that in a better way. For instance, here in Rio de Janeiro, we have adopted this sort of vessel here, and this one as well. So that depends on the availability of vessels that we have at the moment. And there were situations where we even didn't use the vessel and had to rescue a buoy without any vessel. So that's just to illustrate how we operate in the different locations. Regarding the data availability, all the information for SiMCosta is available at our website, which is www.simcosta.furg.br, and all the data is free to the public, so anyone can access the data. And in the site or in the portal, you can visualize the data. We have a lot of facilities where you can plot all the variables. You can specify the period that you want to plot. So it's very user-friendly. We do have automatic data quality control, and we also provide technical support for the end users. Here at the bottom left corner, we have some statistics for the last 4 years, and we tend to have quite a lot of users using the website. What we have here is the timeline of all our buoys or tidal gauges, and we can see here that the project is started piece by piece. So it started in 2015, and those are all the locations where we have buoys: Rio Grande do Sul, Santa Catarina State, Rio de Janeiro, Bahia, and so forth. In blue, we show when the buoy was operating properly, and in gray where we had any problem or maintenance for that buoy. And on the right side, we can see we can see the operationality time of all the buoys, and on average, they tend to be above 70%. Regarding data quality control, we have sensor calibration, and that's generally made abroad. On top of that, we have in situ an in situ validation program. We do biofouling control in all the equipment, and regarding QC, we adopt the CARTOD, which is part of the IU's methodology for data quality control system. So SiMCosta has a lot of users in a wide variety of users. The first ones are those related to the universities, that can be students, teachers, researchers. We also provide information for the environmental agencies that are used for coastal management applications. We tend to have a lot of users that use this information for sports competitions, and a very good example was the Olympic Games that happened in Rio de Janeiro in 2016. The Brazilian Navy uses SiMCosta data for wave modeling and weather forecast. Port authorities use the data for estimating the dynamical draft and for dredging activities. And on top of that, gas and oil companies also use our data for modeling and general operations. It's important to mention that SiMCosta is a member of various international programs and national programs. The first one is Rede Clima, which is the Brazilian climate change network, and also on the national level, SiMCosta is part of the Brazilian GOOS. And on the international level, SiMCosta is part of the Coastal Ocean Observatory for Climate, CO2, and acidification for the Global South Society, the All Atlantic Coastal Observing and Technology Network, as well as Coast Predict, which is one of the endorsed programs of the UN Ocean Decade. So, as news for the SiMCosta, I would like to highlight a few news. The first one is the agreement with the City Hall of Rio de Janeiro that was signed this year. The second one is the workshop of monitoring systems and modeling of the Brazilian coast, our first workshop that was held in 2021. We also are planning to have two new spotters so far buoys that will be deployed in Northeast Brazilian coastal waters in the following year. We just signed a 5-year agreement with Rio Grande do Sul port called Porto Rio Grande do Sul. And also, as Dr. Sejan mentioned in the first day presentation, we just approved the national, a project, or more like a network that is called National Oceanic Observation and Monitoring Network. And I'll talk a little bit about all of these 5 news now. So the first one is the agreement with the City Hall of Rio de Janeiro. So here is the situation room in Rio de Janeiro. And the idea is that real-time data from SiMCosta will be used to monitor the sea state in coastal waters of Rio de Janeiro in order to offer to decision makers the possibility of prevent or to alert extreme events that will be, or that can be happening in coastal waters. The second one is our first workshop that happened last year. It was a 2 days workshop held in November 2021. And in this workshop, we had 13 presentations, 4 from the SiMCosta team, and 9 of them that were presentations based on applications of the end users of the data. And the good news is that we had nearly 150 attendants, and the attendants were mainly, or more than half of the attendants were students, and the other half it was divided in lectures, people from the public sector and the private sector as well. And it's very important to highlight that SiMCosta with this facility through the website is very user friendly and attracts a lot of students, and this is reflected in that workshop where we had more than 50% of students attending the workshop itself. That's the design for the spotter so far buoy that I just mentioned, that will be deployed in the northeast Brazilian coastal water in 2023. And this buoy will not only monitor wind, waves, and barometric pressure, but it will also monitor temperature throughout the water column, as well as the bottom pressure. And last but not least, I would like to talk a little bit about the network that Professor Sejeng just mentioned, which is the National Oceanic Observation and Monitoring Network. As he mentioned, most of the programs that are part of this network are programs that belong to the GOOS Brazil, such as Pirata, the National Buoy Program, the program for sea level, and so far, and SiMCosta as well. So in this network, we managed to put together nearly 100 researchers from 21 different institutions spread all over the Brazilian coastline. The main objective of this network is to establish an integrated network of observation and monitoring along the Brazilian coastal zone and the South Atlantic and tropical oceans, where the idea will be to collect and distribute freely and online high-quality oceanic and atmospheric data, as well as products that will serve the public and the private sector. In the way that the network is designed, we use the structure or the new structure of our regional GOOS office, which is divided in platforms. So we do have autonomous platforms such as drifters and gliders. Another part is the remote platforms, the satellite data and drones. And the two remaining platforms are the fixed platforms, such as moorings, the meteorological stations, and sea level or tidal gauges, as well as the moving platforms such as ship of opportunity and the oceanographic vessels as well. So that's more or less the structure of the program itself, and it's important to emphasize that the main idea is to organize all this data and make that data publicly available. So in this picture, we can see all the institutions in green, which are part of this network, and the other colors, they show the different platforms that we use. That goes from red, for instance, which are the tidal gauges of SiMCosta. The red triangles are the buoys from Pirata. The blue ones are the buoys from the National Buoy Program, and that's the way that we distribute all the platforms. So in summary, the main highlights that I would like to stress that result from the SiMCosta program is that we managed to put together a pool of academic institutions that have similar goals. We managed to monitor essential climate variables along the Brazilian coastal waters. We provide consistent quality data control system, which is very important. We managed to form a team that is very that has a lot of experience in maintenance and monitoring, and throughout the time that the project, we managed to form or to include a wide variety of partners and sponsors. Those are the national sponsors of SiMCosta, which are Rede Clima, the Ministry of Science, Technology and Innovation, CNPq, and CAPES as well. And on top of the national sponsors, we also have the regional, or what we call the local sponsors, which are the Port of Rio Grande and the Port of Rio de Janeiro. So I think that would be more or less what I would like, or what Carlos Garcia would like to present. And now I'm open to questions. Thank you very much.
Thank you, Mauro. Does anyone have questions, or were there any online?
Gabriela, this is Sammy. I don't think I see any questions on YouTube, but I would defer to our MCTI colleagues if they've seen any come in. Thanks.
No, we can proceed.
Okay. So next, we'll continue with Mauro to present on monitoring the regional variability of heat transport and volume in the surface layer of the South Atlantic Ocean. So back to you.
Sorry about that, people. That wasn't the original idea. Let me share the screen again. Can you see full screen?
Not yet.
No? Oh, hang on a second. Sorry.
Você vai ter que compartilhar novamente.
Yeah. I forgot about that.
Ok. Focar em modo. Okay.
Now you see full screen.
Yeah.
Okay.
Yes.
Thank you. So in my second presentation, I'll be presenting what we call on the national level the MOVAR project, and MOVAR stands for monitoring of regional variability of heat and volume transport in the upper layer of the South Atlantic Ocean. And internationally, MOVAR is known as the NOAA AX97, and this project only happens because we have the collaboration of a lot of partners. The first two, my university, the Federal University of Rio de Janeiro, as well as the Federal University of Rio Grande. We also have as partners the CNPq and the Ministry of Science, Technology and Innovation, as well as NOAA and the Brazilian Navy. So the main goal of MOVAR, or the NOAA AX97, is to estimate the heat and volume transport of the Brazil current based on a long-term high-density XBT transect that goes from Rio de Janeiro to Trindade Island. As specific goals of the project, we intend to increase our knowledge of the variability of the Brazil current and the large-scale circulation of the South Atlantic subtropical gyre. By doing so, we can compare the results with other ocean basins, and we can also use MOVAR data to assist in the evaluation of models that can go from high resolution models to climate models, as well as satellite products in the regions such as SWAT. So in the top left picture, we see the distribution of XBT lines, and that's a global network. So here's our AX97 transect, and that's the latest configuration that we have for all the XBT lines, and that was defined in the last oceanauts that happened in 2019. It's very important to emphasize that MOVAR represents the longest continuous monitoring program of the Brazil current, and that was started in 2014. Until now, we have a total of 90 cruises, and during these cruises, we managed to launch more than 4,000 profiles of temperature, which after QC are nearly 4,000 profiles. We also managed to include or to train 100 riders, and that's a very important component of the project as well. And on the bottom right side of the picture, we see all the time series of all the cruises, and every blue rectangle represents a given cruise in a specific year. So on average, we tend to have 6 cruises per year. And of course, as I mentioned before, during the COVID-19 period, this frequency was reduced a lot, but we do manage to keep the cruises in a minimum pace, such as 2 or 3 cruises per year. But at this year, we are getting back to normal, and we should have at least 5 cruises for 2022. So how does it work? So the first thing, we only have a temperature profile. So how do we estimate the geostrophic velocity? in order to get the best quality data, we follow the XBT operational best practice for quality assurance, which was just released this year. It's a paper from Parks et al. 2022. Then we proceed with the fall rate equation, and we apply necessary conditions in order to guarantee that we have the best temperature profile. We then need to estimate the salinity, and we obtain the salinity from temperature using a method that was proposed by Garcia et al. In 2018. And having temperature and salinity, we estimate the dynamic height, which is calculated from the temperature and salinity profiles by imposing the reference depth at 500 meters. And at that depth, we use the monthly climatology of absolute dynamic topography, which is based on the methodology that was proposed by Garcia et al. 2019. And by doing so, we obtain the absolute geostrophic velocity, which is calculated using the thermal wind equation. As we can see, we do have a lot of uncertainties in this calculation. So it's important to emphasize that this whole calculation is very sensitive to various parameters. So in order to reduce this uncertainty, during this year, we adopted a genetic algorithm to optimize this calculation, which is based on Cruise 2022. And what I'm going to show here is the results of, the best results that we obtain. In the top plot, we have the dynamic height difference. So we use the aviso data as our reality, and then we compare that with the AX97 data. So in this first plot, we have the difference in surface dynamic topography along the Brazil current. And we can see that when we calculate that based on AX97 data and aviso data, we can reach a correlation of 0.74%, which is really good. And that was the best correlation that we managed to obtain using this genetic algorithm. There are two ways that we can compare the results. The first one is by comparing the difference in surface dynamic topography along the Brazil current, which is more suitable for volume transport calculations. And the second approach that we can use is to evaluate the mean gradient of the surface dynamic topography, which would be more suitable if you want to estimate the best velocity. So in our case, we decided to adopt this methodology and compare and evaluate the data by using the difference in surface dynamic topography along the Brazil current, comparing the AX97 data with the aviso data. So by applying this methodology, we can recalculate the velocity for the whole data set. And that's an example of what we do, or what we call as the cruise summary, which is a very practical visualization tool in order to have an overview of a given cruise. So what we have here is the example of a cruise in October of 2019, where we had an intense Brazil current. So on the right upper side of the panel, we have the geostrophic velocity. In blue, we have the southward velocity. Here on the left upper part of the panel, we have all the profiles. In blue, the profiles that passed quality control, and in red, the profiles that failed quality control, so that we can have an idea of where we are estimating the Brazil current with confidence. So, for instance, in this part of the current, we don't have data available, so we have to interpolate in this part. So that's a very useful plot where we can see a lot of properties. For instance, like the difference in temperature. Here we have the temperature that was sampled in the cruise compared with the climatology. So in this region, we can see that the water column was colder than the climatology, and along this region, it's warmer than the climatology. And finally, what we have here is the volume transport of the current along the transect, and that's the transport integrated from 0 to 500 meters. So as a result, and if we perform a mean of all the 90 currents, what we have is this plot where we show the mean Brazil current on the left side. Here is the Brazil current, and the data goes down to nearly 800 meters. The bottom part of this plot is filled with climatology, but that's very useful for us to understand the western boundary current that has a Brazil current flowing southward, a deep western boundary current flowing southward as well, and an intermediate western boundary current that flows northward. And on the right side, we have the variability of the current, and we can see that the variability is as intense as the current itself. So another useful plot is the transport itself. So in blue, we have the time series of the transport, the net transport, which results in a mean transport of nearly 5 Sverdrups along this whole period. And it's important to mention here that a considerable part of the current flows what we call onshore of the AX97 transect, which is this part here. So that's a way. That's a very important information to know that at least 17% of the current flows onshore of the beginning of the NOAA AX97, which is around the 200 meters isobel. So to counteract that and improve our sampling, since this year we started to launch XBTs at the continental shelf itself. So and by doing that, instead of extrapolating the data, we can interpolate the data in this region and improve the accuracy of our estimates. So another way of looking for the transport time series is to evaluate the ageostrophic component of the transport. And we did that by evaluating the Ekman transport. And we can see here, which is the black line, that the what we call the ageostrophic component of the Brazil current, it has a minor contribution. And when we plot the transport in two ways, the net transport and the southward component, and when we look at those few red dots, we can see the cruises where we had mesoscale variability. So in this case, we were able to track edges in 26% of all our cruises. So an important part of the variability of the Brazil current is related to the seasonal cycle. So in the first part of this plot, we have the summer estimates, followed by the autumn estimates, the winter estimates, and the spring estimates, and we evaluate the transport in 4 different ways. The red one is the total southward transport, all the flow that's going southward. In green, we have only the geostrophic southward transport subtracted from the Ekman transport. In blue, we have the total net transport, and in yellow, we have only the geostrophic net transport. And what we can see here is that there is a slight variability related to the seasonal cycle, where we have the Brazil current being stronger during summer and spring seasons. In the season, the mean velocity of the current can reach values of nearly 0.5 meters per second. Another important contribution in the variability of the Brazil current is the interrenal variability. And here we have a time series of 5 different indexes, which are the Southern Oscillation Index, the Southern Annual Mode, the North Atlantic Oscillation, the South Atlantic Subtropical Dipole Index, and the South Atlantic Ocean Dipole Index. And although the Brazil current can be correlated to all these 5 indexes, the index that presented the highest correlation is this 4th one from top to bottom, which is the South Atlantic Subtropical Dipole Index, where we found a correlation of nearly 0.6 with a 5 months lag. And the one that presented the lowest correlation was the North Atlantic Oscillation, where we found a correlation of only 0.2, and the best correlation was found with a lag of 10 months. So, 2 important questions that need to be answered is where the MOVAR or the NOAA AX97 data is used. And the first thing is to study the Brazil current, its variability, and the associated oceanographic process. The data is used a lot in the data simulation schemes that are carried out by most of the ocean models from the main forecasting centers that are distributed throughout the globe. And these forecasting models can be either regional, basin scale, or global scales, And the main idea behind that is to reduce the errors, not only in the short-term forecast, but also in the long-term reanalysis. The NOAA AX97 data is also used in the Global Oceanographic database, and that is used to evaluate various quantifications, for instance, such as ocean heat content. And not only that, we also use the AX97 data to evaluate the ocean forecast and analysis systems, which are the high spatial resolution models, as well as the Earth system models, which are the lower, so-called the lower spatial resolution models. And here we have an example of all the forecasting systems that are available for our region. We have 9 different forecasting systems, and what we see here is the AX97 mean velocity plot compared with the HICOM NCODA mean field. And we see that in the case of HICOM, it tends to model a higher but shallower Brazil current, and in the case of HICOM, the intermediate western boundary current is intenser than the current that we were able to measure at the AX97. And finally, what is the engagement of AX97 both at the national and international level? On the national level, like I mentioned, MOVAR is one of the programs that are part of the Brazilian GOOS. And on the international level, the coordination has an active role in various international groups. The first one is what we call the XBT Science Team Group. The second one is the International Quality Control Ocean Data.
Professor Mauro, você me ouve?
Alô?
Pode voltar um pouquinho? Só mais um slide que nós travamos aqui na nossa tela.
Ok?
Uns 2 parágrafos, por favor.
Aqui?
Não precisava encerrar o compartilhamento, não. Só voltar uns 2 parágrafos na sua fala.
Here, Irã? Aqui?
Você pode voltar a compartilhar a apresentação, por favor.
Pode voltar de onde você estava, Mauro.
É
que a gente teve Sim, a gente está vendo e ouvindo. É porque teve lag. Sorry, guys, we had a lag on the YouTube. So, as yesterday, we had to ask for Mauro to restart. Actually, not to restart, but resume his presentation.
Sorry about that.
Yeah. No, we are sorry. You're doing fine.
I was nearly there.
Thank you, Mauro. Sorry.
So, as I was mentioning, MOVAR is part of the Global Temperature and Salinity Profile Program. We are also part of the steering committee of Coast Predict, which is one of the programs that are endorsed by the Ocean Decade. And last week, I was nominated for the ISCOR Committee on Capacity Development. So that was more or less what I had to present, and I'm open for questions. Thank you.
Thank you so much. Are there any questions?
Gabriel, we have Gustavo Goni raising his hand here. Can you see that?
I don't see it, but Gustavo, please, go ahead.
You have to open your microphone, Gustavo.
There. Hello, everybody. Thank you very much. Thank you, Mauro. And I just wanted to, we are part at AML of this project, as Mauro mentioned, and I believe that the knowledge and energy that Mauro has had for a long time is partly what has kept this MOVAR AX97 project be maintained, and also obtaining results from end to end. We go from the operations, the engineering component, to doing research, data management, and then science results. And for that, thank you very much, Mauro. I just wanted, unless I missed it, that I want to mention that we have hosted personnel from Brazil to discuss and for training for this MOVAR transect, and that we are currently, NOAA is fully supporting a student whose PhD dissertation is actually using MOVAR AX97 data, and we are extremely glad that this has been done. And one of the several, I would say, highlights of having this student and interacting with Ivanis, Pita, the student, is that after 20 years of this collaboration with between NOAA and MOVAR, we are also in some aspects using the knowledge that we have gained to apply it locally to observations that we are conducting in a similar fashion in the Florida current. So it has had this cooperation between these many institutions in Brazil and NOAA. It has not only served to monitor the Brazil current, that is a very key component of how the ocean transport the heat from the subtropics to the subpolar regions, but also help us at NOAA in several aspects to better understand the similitudes between ocean dynamics in this region and the Brazil, and do comparative studies and study regional impacts on weather and ecosystems. So for that, Mauro, thank you very much again. I will really appreciate your leadership in this project.
Thank you, Gustavo. Well, it's very important to mention two things. The first thing, we were only able to keep this project for nearly 2 decades because we had Mauricio working for more than 10 years, providing a very solid beginning for the MOVAR. And on top of that, the support that we get from NOAA is crucial. So it's this partnership. It's very important. Like Gustavo just mentioned, we have a lot of student exchange. On top of that, we have the XBT science team, and we used to have Gustavo. I hope that we will start having it again in 2023. The conferences where we get together the whole group, and that was amazing. It's crucial for motivating everyone. So I really missed our workshops, and that's very important. And it's only possible if we have it face to face. While remote workshops are really good, the face to face workshops are much better. So I really miss our workshops, and I'm hoping that we'll get together soon in 2023. And thank you, Gustavo, for all the help.
Thank you, Mauro. Thank you, everybody.
Yes, I know there's many of us looking forward to the in-person interactions again when we can do that. So I don't see other online questions. So thank you, Mauro. And I think we'll transition to now Dr. Charles Stock, a research oceanographer at NOAA's Geophysical Fluid Dynamics Laboratory, or GFDL, who will talk to us about the Climate Ecosystem and Fisheries Initiative.
Great. Can you hear me okay?
Yes.
Great. And can someone maybe allow me to share? I still have I don't think I've been enabled for screen sharing yet. I could try.
Now you can try, Charlie.
Okay. It says I'm now sharing. I'll hide that. Can everybody see this slide all right? Great.
Okay, thank you.
And so I can't see you while I'm in this. So if I somehow lose connection, Sammy, if you could just send me a Google chat or something. I always find it unnerving to not see anybody. But all right, well, thank you very much for the opportunity to speak with you a bit today. I'm just going to set my timer here. And I want to talk about what's really a proposed initiative with some seed funding called the Climate Ecosystems and Fisheries Initiative. And really at the core of it, it's about how to anticipate and adapt to changing ocean ecosystems. And I'll present this. As you'll see, it really involves a large number of folks working together across NOAA in what we hope will be a positive change in our capacity for climate-informed decision-making around marine resources. So I always like to start talking about this by reminding people to thank their local ocean. Global warming would be far worse were it not for the ocean. It's absorbed well over 90% of the extra heat as a result of increasing greenhouse gases and essentially buying us time as we grapple with these issues. And over 30% of the anthropogenic emissions of CO2, which is essentially ameliorating the effects of that greenhouse gas. But of course, as everybody here knows, this has come at a price, and that's the warming of the ocean and the acidification of the ocean. And one of the things we do at NOAA and at the Geophysical Fluid Dynamics where I am is develop Earth system models to project into the future. And they've told us that if we continue on high emissions pathways, we can expect warming of order 3 to 4 degrees Celsius, acidification of order 0.3 to 0.4 pH units, deoxygenation in many parts of the ocean, and changes in ocean productivity that could change fisheries baselines. Now, one of the challenges we face now is that we're really transitioning from a situation where climate change was sort of a looming global threat to one where it's a contemporary challenge that's generating regional questions about our marine resources that we need to start to be able to inform today. And this slide just lists some of the ones that we've been discussing a lot in NOAA and in our discussions about the CFI. When should legacy fisheries be closed and new ones opened as fisheries change distributions and productivity? How should harvest control rules be adapted for changing distributions and productivity? What management strategies will be effective against worsening climate extremes? Where should I fish to limit interactions with recovering or protected species and be able to catch the ones that I can catch sustainably? and will increase risks of HABs or pathogens, put planned aquaculture at risks as we look forward 20 or 30 years into the future. And so as we pondered these questions, which we were starting to encounter from our stakeholders, we began to look back at how we're developing the tools that have informed those questions in the past. And while I would say that there were some really great examples of successes in some regions and systems, in general, it was a very fragmented and mixed story, in part because a lot of our efforts in these areas were being supported by short-term grants for sort of innovative work. But what we needed to think about was how to design these systems to meet a sustained and growing need. And that's really what was at the heart of this Climate Ecosystems and Fisheries Initiative plan, was how do we develop this end-to-end system that's depicted graphically here, that starts from what's the regional ocean modeling there at the left, which is really providing the predictions and projections at the spatial temporal scales required to inform those regional decisions we need to make. Having a standardized information hub to be able to serve standardized model outputs at a national scale that our stakeholders will be there when they need it, and they'll know how to interpret it when it's there. And then, of course, beefing up the decision support teams, the scientists responsible for translating ocean predictions and projections into actionable information for managers and decision makers as they interact with our coastal oceans. And then a big part of this was having targeted research and observations, really supporting all elements of this process. Now, as I mentioned, this is a nascent effort, and I'm going to be able to describe the basic steps that are involved and highlight some of the progress that's been possible with some of the seed funding that's been obtained. But we are a little bit contingent on some big budgetary discussions that are presently ongoing in Congress. And depending on the outcome of those, this will either be a very large initiative or something more modest, but hopefully still effective. So let me kind of take you through some of the steps here and highlight some of the progress thus far. So with the modeling perspective, the challenge really comes down to providing predictions and projections over a range of management relevant spatial and temporal time horizons at a national scale. And this plot here on the right-hand side, I believe you can see, can you see like a red light or a cursor when I move this? Maybe not so much?
Yes, I see the cursor.
Okay, great. So this plot just is a summary of different decisions that need to be made in the marine resource realm, fisheries realm. On the x-axis here is a time horizon from days to weeks out to centuries. The different colored circles here are different contexts in which decisions need to be made, from industry operations, monitoring enclosures, annual catch limits, rebuilding plans in protected areas, industry capitalization, and resilience and sustainability. And these clouds here are just a depiction of the various climate processes that are prominent at those space and time scales. And what the CFI has proposed is really taking a cross-NOAA approach in order to fill this space. And going up from the right-hand side here on the nowcasting and short-term forecasting, it's really an expansion of the National Ocean Service-led ocean nowcast and forecast systems out to subseasonal timescales. It's timescales of about 45 days or so. And then on this end, we've proposed harnessing OAR's Earth system modeling capabilities, bringing them to a regional scale to cover the seasonal to multi-decadal time horizons, and then including some targeted enhancement of global ocean prediction systems, most notably integrating biogeochemistry into our global seasonal to decadal forecast systems to provide critical boundary information to regional simulations. Now, most of the work thus far that I've been involved with anyway, has taken place on this upper limb here. How do we take our Earth system model components, start to apply them at a regional scale, and in both a predictive and a projective, meaning multi-decadal projection context? For this, we've been relying on the Modular Ocean Model 6, which I understand you heard a little bit about from Bob Hallberg yesterday, and Bob shared that there are a number of Brazilian scientists who are actually actively using MOM6 in innovative ways, and so that was really good to hear. we're leveraging it for a lot of reasons, one of which is that we think it's a really great ocean model. But the other critical part to the sustainability of the effort is that MOM6 has adopted an open development paradigm, which is a very non-trivial step to take to be able to open your model for others to come in and improve it and have the required steps and safeguards for those improvements to come in and improve the model and not compromise it. And so of all the plots I could have shown for MOM6, what I've shown here, this is actually a GitHub diagram. So it's basically the version control system for MOM6. And around this, you see various collaborators from academic centers to big national laboratories, which are all invested in this co-development approach for what should be a lasting ocean modeling and prediction infrastructure that we want to build this lasting ocean prediction and information infrastructure upon. This system also includes comprehensive biogeochemical components that were developed first for global Earth system models, but are being adapted for regional runs. And this is actually close to my heart. I am a biogeochemical modeler by trade, and one of my roles at GFDL is to help co-develop the biogeochemistry for the system. But this capability allows us to look into things like acidification, deoxygenation, comprehensive nutrient cycles to handle changes in phytoplankton productivity, and of course, biological carbon pump and the supply of energy to the benthos that fuels a lot of critical demersal fisheries and shell fisheries and so forth. And so this infrastructure is included within MOM6. MOM6 is designed in a way that it can handle a comprehensive biogeochemical model without breaking the computational bank. And we've had some fair degree of success deploying it across multiple regions. Regionally, the approach that we've decided to take was to try and focus efforts around 5 relatively large-scale grids. A lot of our efforts to date have been fairly granular, I would say. That there's probably a mix of several dozen different configurations of different models in common use for fisheries applications. And it's not that we want to squelch that innovation and information that comes from those systems, but we feel like we need to make sure that there is a national scale backbone of critical information available everywhere, which can be augmented and improved regionally. But right now, there are many systems that just don't have the same resources that others do. And so focusing on 5 large-scale grids provides us a way to ensure national coverage, ease the operational requirements, address the cross-boundary issues that are critical under climate change, while still allowing us to get resolution sufficient for shelf-scale fisheries applications. And the grids I'll show you in a moment, we're able to run at, say, 5 to 8 kilometer resolution for these large-scale grids and still be able to churn out, 4 or 5 simulation years per day so that we can create projections and predictions over the range of potential ocean futures to inform those marine resource decisions. And each of these would be shepherded by sustained regional ocean modeling teams, drawing in regional experts, and then that could be bound by a national community of practice. And at the end of the talk, I'll also talk about the potential for international communities of practice to feed into this in various ways. For instance, I heard many of you are already involved in Coast Predict, and there are a number of other programs that I think can cross-fertilize some of these efforts. Started to build these regional ocean modeling teams, drawing on a similar plot to the one Mauro showed for the observational infrastructure. But we've been building up a large number of collaborators with expertise in each of the coasts and systems who are taking the lead on different configurations and coming together bi-weekly for regional MOM6 development meetings to try and push this effort forward. So we're sure to hit the ground running when CFI is hopefully fully supported. These are the grids that we've been developing for 3 of our systems thus far, and this was made possible by a number of seed support that came from our climate portfolio in NOAA, as well as the Climate Program Office and our laboratories within OAR. And again, these are being developed by scientists across OAR, not just at GFDL, but for instance, the East Coast configuration here, which as you can see is very coast-wide, includes the entire Caribbean. Unfortunately, it does presently not cover that much of Brazil, but but you can see the sort of scale that we're able to get at about the 5-kilometer resolution. And if we harness NOAA HPC, we can run these for long integrations that are required and for the ensembles that are required. When we add biogeochemistry to this, that very comprehensive model, it increases the cost by only a factor of 2 or 3 because of some clever coding that Bob Hallberg and others have done in order to enable the coupling of large amounts of biogeochemical tracers efficiently. Now, that was initially done for multi-century integrations at a global scale with our system models, but it is equally useful at this regional scale. These systems are in various levels of maturity. We have a special issue in geoscientific model development scheduled for 2023, where we plan on publishing the initial baseline configurations from these that will again arise from this large-scale effort across OAR labs, across NOAA, and our academic collaborators. The data portal, we are building off of a climate change web portal system that was originated at the Physical Sciences Laboratory in Boulder. The website is down here. This diagram shows some results from an earlier effort that was one of these, one-off proposal-based efforts on the East Coast, where we're serving the data from that, which is predominantly physical data, doesn't always follow your standard climate change CMIP guidelines. The variable names they change between different regions. The amount of data changes between different regions. The CFI will harness this interface, but standardize that data provision at a national scale so that whether you're a stakeholder on the West Coast, the East Coast, or elsewhere, you'll be able to rely on getting the same types of data across the time horizons that are management relevant. And then a big piece of this, which largely will take place within our colleagues in NIMS, National Marine Fisheries Service laboratories, and NCOS laboratories and NOS, folks involved in connecting ocean predictions and projections to marine resource applications, is really beefing up that capacity to translate this information into management relevant, decision relevant information that can improve our decisions under climate change. Really quickly, I'd just like to share a couple of examples that have sort of inspired us to go down this route. This is a simple set of plots that emerged from a study led by Desiree Tomasi, who's now at our Southwest Fisheries Science Center. But what Desiree did, I'm going to focus on some shorter timescale examples to try and highlight the tactical uses of this sort of information. Desiree was looking at a small pelagic fishery, the California sardine, notoriously volatile in response to climate variability. And with this one, there was a SST-based metric that was actually worked into the current stock assessment guidelines. And Desiree just asked a simple question, this time with a global model, because California was oceanic enough that she could get away with it in that system, where she said, okay, what if we had a harvest control rule that didn't consider any ocean information, this no sea surface temperature, no SST case, one that just considered past SST, and one that considered past and forecasted SST with a skill consistent with our present global modeling systems. And what she's plotted here is the expected yield and the expected stock biomass derived from a management strategy evaluation. So you can think of this as your economic goal, the yield, and the stock biomass is sort of your conservation goal. And she was able to show that as you add in this environmental information, you're able to increase the expected value of the yield and the expected value of the biomass. Now, it might seem like we have violated some sort of space-time continuum here, conservation law, broken the fabric of the universe, but no, we've brought in additional information that has allowed us to make better decisions in this case. And this is the CFI is trying to do that at scale, nationally at a high resolution. So I think this is a simple but a powerful example of new information allowing a win-win situation where both conservation and economic goals can benefit. This is just another quick example where we took advantage of biogeochemical prediction capabilities. Again, this was at a global scale. This was for another small pelagic fishery, this time off the Agulhas Current in South Africa. And I'm sorry, I should have had the reference here. Jong Young Park and colleagues showed was that when you considered both the sea surface temperature and the chlorophyll in this case, again, because this is a biogeochemical prediction system, you don't just have the physical properties, but you begin to bring in those biogeochemical properties. You could anticipate fluctuations in this particular forage fishery up to 2 or 3 year leads. And basically it's a signal that propagates in a deterministic way across the Indian Ocean that leads to a deterministic response at the tail end of that and seems to have produced a predictable response in the fisheries. Now, of course, as one moves to longer timescales, the sample size does get smaller. So we do take that with some humility. This last quick example here looks out to the decadal scale. And I think in general, we all know that the decadal prediction is difficult. There's a lot of variability at decadal scale. The climate change signal isn't always as prominent that they can give you predictable scale. But what, again, Desiree Tomasi in this case asked was a very fisheries-oriented question. Will the next 10 years be warm relative to the last 50? A lot of our existing fisheries records, in many places anyway, are based on time series that have reached the multi-decadal level. And for questions like, will a previously prominent fishery come back, or is it gone and should we open a new one? This sort of 10-year time horizon relative to that 50-year record is a really critical one. And what we again found this time with, again, global models, but we're trying to eventually replace them with high-resolution regional models, is that for many systems, we could say something meaningful about what the next 10 years were going to be like relative to the last 50. It didn't mean we were necessarily predicting things like the North Atlantic Oscillation or AMO. In many cases, it meant that our climate change signals are strong enough at this point that we can say meaningful things about the next 10 years relative to the last 50. So I was first very happy to see this result. When I thought about the reason why it's so skillful in many places, it sort of damps your enthusiasm because in many cases it is because the climate change signal is so strong. But it's examples like these that have driven us to be pursuing the CFI in the hopes that we can provide this information robustly for the range of applications that we need to think about over the next 10 or 20 years. Very quickly to conclude, I just want to point out that there is a UN decade activity sponsored by NOAA called SUPREME, Sustainability, Predictability, and Resilience in Marine Ecosystems, which in short is really meant to bring a global community together around this end-to-end idea, stretching from the ocean predictions to the marine ecosystem applications. And so there's obvious connections with Coast Predict and things like FLAME in the UK. I think hopefully the unique aspect of what Supreme can bring to the table is really bringing in both the ocean prediction and the fisheries responses to provide that end-to-end system. And Hannah LaChance and Stephen Bograd are really leading this effort, and it might be a good way to link up with some of the nascent efforts within CFI. So with that, I'll stop, and I hope I didn't go too long.
No, that was great. Thank you, Charlie. I do think in the interest of time, we will hold questions until the end in hopes that we might have some time for discussion. So with that, I would like to invite Emily Smail from the GEO Blue Planet Executive Director to talk about the Group on Earth Observations, or GEO, and the Blue Planet Initiative within that.
Thank you, Gabrielle. Let me just share my screen. So thank you, everyone. I'm going to give an overview of the Group on Earth Observations Blue Planet Initiative. So GEO is part of an intergovernmental partnership that works to improve the access, availability, and use of Earth observations for society. And GEO really tries to promote open access and data sharing for information, for the benefit of all, in support of decision-making, including policies. And GEO has 3 or 4 now primary engagement priorities. One is the United Nations Sustainable Development Goals, the Sendai Framework for Disaster Risk Reduction, the Paris Climate Agreement, and the New Urban Agenda. The way that GEO works is that it invites the member countries, so there are over 100 member countries, as well as participating organizations, which are groups who use or produce Earth observation information, such as a lot of the United Nations groups, to form different initiatives that focus on certain topics. And they call this the GEO Work Program. And so within the GEO Work Program, there are activities that are devoted to a lot of different topics. And GEO Blue Planet is the one that covers the ocean and coasts. Other groups include Biodiversity Observation Network. There's also one on agriculture. So it's really a cross-sectoral organization. So within GEO Blue Planet, we work to try to bridge the gap between ocean and coastal observational data and societal needs to try to deliver actionable information. And GEO Blue Planet is a global network. So participation is open to anyone who's interested in contributing. And we currently have representatives from the ocean and coastal observation arena, social scientists, as well as some end user representatives. We have a secretariat that is hosted by NOAA and the University of Maryland through the Cooperative Institute for Climate and Satellites. And so we have had that office going since 2015. In 2020, the European Commission provided funding for a secretariat office, which is hosted at Mercator Ocean International. And we are also in the process of setting up an Asian secretariat office that is going to be based at the Korean Maritime Institute. And so what we do for GEO Blue Planet is to try to get stakeholders to understand what Earth observation information can do, and then to follow up with them to get information about what types of tools that they need. Are there available data sets already that they could be leveraging? And we do focus on least developed countries as well as small island states. And the way we organize our activities is in 3 what we call action areas. And so stakeholder engagement, where we try to understand what priority information needs are. Once we identify information needs, we then try to work with various stakeholders to do design of tools that support user needs, and then we also do capacity development. And so this is an overview of the top types of offerings and activities that we do. So for stakeholder engagement, we do a lot of workshops and symposiums. So for example, we do regional symposiums every 1 to 2 years. We just finished one up in Accra, Ghana, and that was involving trying to get feedback from the African continent. We also sometimes get requests on certain topics, and we'll then produce white papers on those topics, such as we had a request from UN Environment to give an overview of the monitoring status and data integration for marine litter. And so we put together a group of experts to do that, as well as general outreach materials. If there is a specific topic that needs an expert group organized, with the Secretariat will help organize that and then also work to support specific tools. We also have developed some information hubs, and I'll give an example of one that we've done for sargassum. And then in terms of capacity development, we look more to support long-term capacity. So trying to find projects where we can do transfer of operational capacities to other activities, or if there is a temporary product, try to bring it on board with an operational agency, and also just to support information exchange. And so over the years, through our stakeholder engagement activities, we have set up specific working groups that are on different topics. And to give an example of how these came about that are applicable to this conference, we had done a workshop in the Caribbean in St. Vincent and the Grenadines in 2018 to try to identify stakeholder needs. And the participants at that workshop said that based on what they know about Earth observation information, after we gave them some examples, they were particularly interested in trying to garner support to increase capacity for sargassum monitoring as well as oil spill monitoring. And so we've worked with the global community, including colleagues at NOAA, to put together expert teams and gather information related to that. And I'll give a little bit more detail on activities moving forward. For our marine litter working group, things that we have done for this so far include a white paper on marine litter data and how that could be put into a platform, which is something the United Nations Environment Program is mandated to do. We also have done a series of marine litter workshops, and that included a workshop on the Integrated Marine Debris Observing System at the UN Ocean Conference last summer. Moving forward, we're going to continue to, try to connect different communities working on marine litter, and I'm particularly interested in trying to support the development of the Integrated Marine Debris Observing System, as well as trying to support marine litter observational needs for modeling and to try to link marine litter and fisheries aspects. For our eutrophication working group, we have been doing this activity primarily in support of the United Nations Environment Program, who are tasked with supporting the methods and data analysis for the Sustainable Development Goal indicator that is on coastal eutrophication. So that one is at 1411A. And so for that, they asked us to help develop some global indicators based on satellite data, since when they were doing engagement with member countries, they found that very, very few member countries actually have nutrient and algal data available that they can use to report on eutrophication. And so we got together experts in the ocean color community, as well as some statisticians, to put together 2 global indicators. And so that data is now being processed in collaboration with ESRI and is included in the UN SDG annual reports every year. We also work with them to produce a storyline on the status of the indicator. Moving forward, we're working on a publication on that, continuing to support the reporting, and furthermore want to develop some interactive dashboards and tools. And so the rationale for that is the UN has to have a specific indicator, but we're really hoping that we can map out the distributions of algal hotspots so that countries can help use that information to tailor where they should do their nutrient sampling. And along those lines, we're trying to support the development of higher resolution, locally tuned products. And we had some funding from UN Environment to do a small sampling campaign that has just been completed in Argentina, Uruguay, and Mexico, where they collected radiometry data as well as chlorophyll and nutrients. And so we will continue to work with our partners in those countries to develop some locally tuned products, as well as to see how well the global indicators are working in those regions. For our coastline changes activity, we have a group that's putting together a global wave-driven flood forecasting product for reef-lined coasts. And we also are working on putting together a broader group that will work on looking at coastal erosion and accretion changes. And that will be done in partnership with a lot of groups that are already doing this, such as Digital Earth Africa, who is working on doing a coastal erosion product for the African continent. And moving forward, we'll continue to work with the development of the Wave Force product. One thing for that is that to have those forecasts, you need improved bathymetry. And so we're working to try to garner communities that are working on satellite-derived bathymetry to try to do that for the islands where they have some clear waters. And as I mentioned, further work on trying to organize the global community doing erosion and accretion monitoring. For our fisheries working group, there was several years ago an initial project looking at the application of fisheries in aquaculture. The acronym for that is SAFARI. And so that's something that's going to be revitalized. They're going to be having a workshop in India next year as part of that. Other things that we have done is we got requested from the Indian Ocean Tuna Commissions for information on Earth observations for tuna fisheries management. And so we hosted a workshop series on that topic. and included people from the Pacific as well as Indian Ocean and Atlantic who are working on it. And we're going to have a colleague who's going to be working on a peer-reviewed publication that will do kind of the state-of-the-art of Earth observation for tuna management moving forward. Other activities the fishing group is working on is we have working group participants at the University of Ghana who have developed a very simple alert system for their fisheries, which is looking at coastal sea state so that they can alert the fishers about safety at sea. And they have it broken down into a red, yellow, and green, you know, okay to go fishing, rough or dangerous. And they set that out through SMS, as well as they now have a phone code that you can call in Ghana to get the alert as well. And that goes through to the fishers, who will then put out flags on the beach for the artisanal fishermen who may be illiterate or don't have access to cell phones. And so our colleagues in Bangladesh were interested in creating a similar system there. So we're working to do a tech transfer project between the University of Ghana and Bangladesh. We also have activities looking at Earth observation and ocean data for fisheries and climate modeling, Earth observation data for culture fisheries. So we're going to work more on the aquaculture side of things. There's a lot of interest from various stakeholders on site selection for aquaculture, for example. As well as to look at developing a roadmap for the use of Earth observation products for fishing detection traffic data related to fisheries management, and then looking at the relationship between marine litter and fisheries. For sargassum, what we have done for this so far is we organized a series of workshops. And through that, there was feedback that there are a lot of different sargassum activities going on, and they needed kind of a centralized spot. And so we created this website, the Sargassum Information Hub, that will continue to update, that has information about sargassum research, monitoring, and we're going to work to improve that and try to release tools. One thing I'll say is that we have this year worked to develop some regional pages. And so, you know, we would be happy to, you know, further develop one for Brazil specifically. And over the next year, we're going to do an analysis of the current products, because there were a lot of efforts that were kind of short-term funded and aren't being operationally maintained. So we're going to look at the findings that researchers had from those and see if we can translate those into some operational products in different regions, as well as to try to work with the community to improve forecasting. And we're doing this across the Atlantic, so both with stakeholders from the Americas and the Caribbean, as well as stakeholders from West Africa. And then further develop the information on the hub, including we're going to translate it. Right now it's only in English, but we're going to have it available in Spanish and French, and hopefully also Portuguese. And for the oil spill working group, so we had a presentation earlier about the Costa project. So that really came out of the GeoBlue Planet engagement in the Caribbean. And we worked to identify that the satellite analysis branch here at NOAA has the capacity to do this training. And so after a few workshops and you know, efforts working with the satellite analysis branch in NOAA, we did some engagement to find potential partners, and I identified, you know, the International Maritime Agency at Trinidad and Tobago as a good partner, and are looking to identify more partners for that. And again, this is related to the project that was presented yesterday. And moving forward, we're going to bring together you know, the working group in a global capacity to try to share additional information, such as some of the information related to data access, modeling of trajectories, and things of that sort. So we'll be really interested in following up with some of the presenters we've had at this workshop about that. And then lastly, we have a workshop, a working group that's currently developed on climate adaptation. So as I mentioned, GEO has these engagement priorities. One of them is the Paris Climate Agreement. And the UNFCCC Secretariat has been putting together different guidance documents to help countries develop their national adaptation plans. And so that's something that we're really going to focus on moving forward, is trying to produce guidance for national adaptation plans for coastal areas, and then also potentially for fisheries. And so far we have had a workshop on coastal services for small island states, as well as I participated in the National Adaptation Plan Expo for least developed countries, and we had some really good engagement with that. We also had a National Adaptation Plan workshop at our symposium in Ghana a few weeks ago. And so this is something that we're going to be working on, as well as doing some policy briefs for COP28, which we're planning to do in collaboration with other ocean observing activities, such as Goose, of course. And then there's also interest in looking at support for blue carbon mapping as part of GEO's general effort to do mapping of ecosystems. And so that's something that we're looking to facilitate. And so that's all I have. I'll take any questions.
Thank you, Emily. I think we will transition directly to the next speaker and then leave, I hope, 10 minutes for discussion at the end and questions. So last but not least, we'll hear from the Secretariat of AmeriGEO, Alberto DeGarmo. Are you? There you are.
Hello, can everyone, can you hear me?
Yes.
Perfect. Just pull up these slides. Perfect. Can you see my slides?
Yep.
Yes.
Awesome. Thank you. Well, thank you all for inviting me to come speak on AmeriGEO. We're really excited to enter in this conversation on the unique role that AmeriGEO provides to the Western Hemisphere and to our member countries, which we are excited that Brazil is one of our member countries that are participating in our group. Emily mentioned briefly on the Global GEO organization, which helps coordinate Earth observations on a global perspective. What we're going into now is AmeriGEO, which has the primary responsibility of coordinating among the member countries, participating organizations and associates that are actively developing capabilities in the Western Hemisphere. And so throughout this presentation, I hope to illuminate on kind of the various functions of AmeriGEO, the unique strategy and perspective that AmeriGEO can provide to the region, and that ensuring that not only are there global priorities of group Earth observations reflected in our work program, but also that we have the opportunity in the venue through AmeriGEO to have the countries in the Western Hemisphere describe what is important to them and ensuring that those efforts and strategic priorities from the region are reflected. So in essence, it's us making sure that the priorities from the global organization are being met while also listening to the region and our members to ensure that our strategic priorities and benefits are being addressed as well. So breaking it down into a little bit function for our conversation today, we have 4 foundational tasks or things missions that AmeriGEO strives to ensure that we are adhering to meet our member countries and ensure that we are delivering that unique perspective. So first is building and strengthening partnerships, and we do that through engagement in both our member countries as well as various organizations. A strong second component is advocating for open data policies. So I'll discuss our perspective and how we are helping to push the envelope in making sure that the region is sharing in a collaborative manner on the data policies that are going on. Third is delivering on capacity to ensure that when we are finding and utilizing the EEO, that we are able to deliver it in a very user-friendly and impactful way. And then lastly, ensuring that we are delivering on knowledge transfer and technology development. And we do that through various methods of capacity development, as well as public and private partnerships. So how is AmeriGEO organized? So we have a similar structure to the Group on Earth Observations Global Framework. but we are slightly different in how we approach. And so overall, we have the Americas Caucus, which serves as our senior most strategic body for AmeriGEO, and this is comprised of principal representatives from all of our member countries. So this is where the heads of the organizations and ministries provide the strategic direction for the organization, ensuring that we are delivering on these specific strategic priorities and societal benefit areas. Historically, we had 4 strategic priorities with biodiversity, ecosystem sustainability, disaster resilience, food security and sustainable agriculture, and water resources management. In 2019, excuse me, the caucus then agreed to add another section, which was our health priority. And so we added that as another priority area in the recent timeframe. And then you'll note on the bottom that all of this is supported by what we see as our foundational activities. This includes the central component capacity development. So this is where we are working on outreach, workshops, training, helping to develop the infrastructure to be able to then impact and provide these benefits and these tools to the region, data, tools, and various services. To give you a quick snapshot into our membership, we have the member countries listed on the screen here. And so all of these organizations and countries are actively participating. I will note that we have our annual event, which is called AmeriGEO Week, once a year. And Brazil actually hosted this event in 2018. And then we continued on. We did shift to a virtual format, obviously in recent years, to pretty strong success, and we've been bolstering participation in recent years. The last AmeriGEO Week that just took place was in Paraguay, and we had up to a total of just over 2,000 participants from all around the world, every single region participating, that listened in either in person or online to listen to the conversation on how we are delivering these services to the region. Upcoming AmeriGEO Weeks, we have our next 3 hosts for this annual event already identified. And so in 2023, we'll be returning to Costa Rica to have this conversation. And the intent and goal for these events is to continue hosting them in a hybrid format. So we'll be having participants traveling to Costa Rica as well as participating virtually. Then in 2024, we will be going to Ecuador, and then 2025 will be in Colombia. As far as our senior leadership at the moment, we have 3 co-chairs that help provide the additional guidance and strategic direction to the organization. And currently we have the United States, Peru, and Costa Rica serving in that capacity. And the individuals are on the screen are the principals for each of those countries. And they provide a little bit more of assistance and guidance to the organization. Underneath the caucus and senior leadership is the coordination and working group. And so this is headed or led by the 3 individuals on the left right there. And they provide the day-to-day or month-to-month management of the organization. And they are supported by the AmeriGEO Secretariat, which I currently serve. And actually, I believe this will be my last engagement formally as the AmeriGEO Secretariat as we are transitioning. So at the end, I included a generic email that you can contact with any questions, and they'll be happy to help you out. And so wanted to get into the activities, what's happening in the Western Hemisphere from the AmeriGEO perspective, and how we are providing a unique value proposition into ensuring that we're delivering on Earth observations. So the first point I mentioned was building and strengthening partnerships. So a key essence and value of what AmeriGEO does is convene the relevant organizations, international groups, private sector entities, and NGOs to work together in a collaborative manner and leverage each other's strengths and unique value to ensure that we are not duplicating efforts and aligning all of our contributions in an adequate and sustained manner. And so in 2020, during AmeriGEO Week, we signed what was called the Aguas Calientes Declaration, and that was between the AmeriGEO and the organizations you see listed on the right. And the intent was for the declaration to highlight responsibilities and guidelines and ensure that we are working together to define further joint work strategies and programs to mutually advance regional integration and to build a spatial data infrastructure comprised of a diverse range of Earth observation resources and geospatial information. This included geographic, statistical, and other thematic information. This has continued to develop. We have a joint action plan now with these various organizations as well. And a number of AmeriGEO member countries have actively been participating in this collaboration to ensure that we are delivering on the goals and aspirations that are outlined in the Aguascalientes Declaration. As everyone here knows, data is the foundation for decision making. So we have been working with our geo principals and national institutions to bring together the Earth observation and geospatial information for use by our community. You'll see a snapshot here on the right that is the AmeriGEOS community platform, which is our attempt to bring and provide discovery and access for the usability of data, tools, and services and resources for analysis and understanding to the region. Right now, this platform includes social, economic, and environmental data, and the platform has over 440,000 resources from 23 countries, including Brazil and other regional members and global institutions. For Brazil specifically, the information and geospatial information is coming from the Brazil National Data Portal. Brazil right now is currently contributing 29,229 data sets, and you'll see on the top right that Brazil is actually the third contributing member in the region for the number of data sets that are being provided. So obviously, thank you to Brazil for being an active supporter and proponent for the system. And our intent is to continue to grow that with our ongoing conversations and collaborations with a number of organizations. Another avenue that Brazil is providing a leadership into the region, obviously, is the GeoNetcast system. And we strongly, obviously, thank you for that. And so in support of, or one of the unique concepts that I previously mentioned was that we are attempting in AmeriGEO or striving to remove the barriers to address gaps in user needs. And we do, one of the unique ways we do this is by providing blended public-private partnerships. And so in support of knowledge transfer and the technology development, our unique role is to bring together those organizations to deploy emerging technologies. And you'll see them on the bottom listed there with cloud optimized computing, artificial intelligence, Internet of Things, machine learning, blockchain technologies, and mobile devices. And the 2022 pilots, and this was done in coordination with Peru, OGC, AmeriGEO, and various other United States agencies, is to improve awareness, discovery, and access, develop analysis-ready data, optimize geo services, as well as to develop decision-ready products, tools, and services. Here are some samples of what we currently have taking place in AmeriGEO. On the right, you'll note various different thematic areas that AmeriGEO is actively engaged with. EO for IM, SAR, CBC, MBON, Pole to Pole, as well as AMA project. I believe this was already mentioned earlier, but another contribution that we are making through AmeriGEO is through the COSTA program, which is the Federated Oil Spill Detection Network that NOAA is working with AmeriGEO specifically on helping to develop. This is going to be a regional program, so we're obviously looking for all the participation and members that are interested in helping to contribute to that. And I believe this was also mentioned, so I'll just spend one slide on it, but this was further supported and generated from an event that took place earlier this year off the coast of Peru with the oil spill that took place, which was, I believe, the largest environmental disaster that took place in Peru. And it was through Peru's collaboration with AmeriGEO that they were able to leverage the shared capabilities of not only the United States agencies, but other regional networks and ministries to help adequately respond to that oil spill. And on the right, you'll see those maps that were produced by that collaboration. GeoGlow's stream flow services, which are large-scale global hydrological models down to field or local scale using local or global data assimilation, are also actively taking place. And the main interagency that GeoGlow's is interacting with in Brazil is SMADEN. And here you see the network that is being utilized for historical validation in Brazil in the stream flow analysis. And then further developing on that, you see the national weather level forecast as well for Brazil that AmeriGEO is actively contributing in through our GeoGlow's program. And for biodiversity and ecosystem, we have GeoGlam, which our lead for the United States is Alyssa Woodcraft. Brazil is also currently contributing to that with Argentina as well. And this is our monthly monitoring service that looks at agriculture monitoring throughout the region. I also want to take a moment on note on our foundational tools and services. Capacity development is a key component of AmeriGEO, and we are looking to help develop the tools necessary for understanding and how to utilize these Earth observations tools. So in 2020, AmeriGEO launched what is called the Inter-American Academy for Geosciences and Applications. And this was born in 2020 after the follow of the advent of COVID-19. And so obviously when the pandemic impacted the region, we had to re-strategize and prioritize how we were delivering capacity development throughout the region, as individuals were no longer able to travel for specific training opportunity. So this is a completely virtual platform, which looks to coalesce and convene all of the all the capacity development efforts that are taking place in the region. And this aims to reduce the barriers for members to participate in capacity development, as it is easier for individuals to participate in various different trainings through this virtual platform. It is a completely free and openly available resource. And while this is provided by AmeriGEO, we like to think of this as a resource for the region, not specifically branded as AmeriGEO. So we have a variety of different opportunities and venues for training. We have on-demand webinars, pre-recorded sessions, and then virtual live instructor-led courses. As we are returning to travel, we also will be incorporating in-person registration for live trainings that will take place face-to-face. And so the intent is for us to utilize this innovative approach to meet the users on where they are at and to deliver this capacity development right at the comfort of their own home. And there are a variety of different applications that are being developed for this academy. And we're continually looking for new contributors and members. So if your organization is interested in not only participating in training, but also providing training, this is a resource for the region that we invite everybody to contribute to and to participate in. As far as our partners and contributing organizations to the Inter-American Academy, we have a variety of different networks and organizations that are currently active within the community. It's not just governmental, but we are also incorporating academic, regional, and private sector. And I know that was a quick flyby. I was trying to give us back some time. So my email is at the end. I'm sure we can share this presentation. So please feel free to email myself or Angelica Gutierrez, and we'll be happy to do a deep dive into AmeriGEO and what capabilities you can provide to Brazil.
Thank you so much for your presentation. We have about 5 minutes. There may be questions. I do see that there may be some online. Karen and Sammy, can you advise about what those might be? And I'd also invite all of today's speakers to please turn on your cameras, and others from MCTI and NOAA who are joining us on the conference platform, please do so as well. I can read a couple of the questions.
Let me just clarify, those questions were here from the YouTube to, I think they're all to Charles actually, and they were from Elena, so you can address them to him.
Okay. And I know we're limited on time, so I'm not quite sure how to handle multiple questions, but we can just jump in. And please, everyone stay on. I know Sammy would like to take a picture at the end to memorialize this event.
Yeah.
So
I would
Charlie,
like to make some general questions, and they could answer perhaps as a concluding remark. That would perhaps give us another 10 minutes if that's okay, or 15 minutes if that's okay for all of you that are online. But from the Brazilian side, I'm sure we are all fine with time. So it's really up
Would
to
you like me to quickly answer Helena's question? So Helena just asked about whether our biogeochemical model was we initially developed for global modeling, which it was, but how useful could it be for regional applications and near coasts? And I would say that it's reasonably robust, but we're always trying to make it better. You know, it's a model that we co-develop with partners, and we're not quite at the fully open development paradigm that MOM6 has, but that is the target. And it has been used in coastal settings on the east coast of the U.S., the west coast, the Gulf of Alaska, a little bit in the Bering Sea, and off the coast of Hawaii. And done, again, reasonably well, but every time we use it, we try and learn from it and improve it. So I hope that answers your question. If you have any more questions about it, feel free to contact me at charles.stock@noaa.gov.
thank you. Karen, can we turn to you for your proposed question?
Yes, thank you. You know, taking a look throughout the 3 days that we had in a row, we had such amazing presentations and so much was shown. And I would just like to comment that as much as science and technology on ocean is developing at an amazing pace, I think that multilateral and bilateral efforts and cooperation is growing as well. And I could see all this great multilateral projects such as Atlantis, Costa, AmeriGEO, GeoBlue Planet that are actually making a big difference in the way we repack science, and that we bring more users and more stakeholders into the dialogue, not only on science making, but on the science and policy interface. So I would really like to congratulate you all for the excellent work that you've been all doing, and extend this congratulations to all the presenters that are not here today, but perhaps they will see this video and see that in the end. But as a general question, then I would like to hear from all of you, and as you feel like responding, please. How do you see that this science policy interface has been growing recently? Are we on the right path and at the right pace? And how much more we could do to bring more people on if that's the need? Perhaps not the more people on, but are we having the right people on board? And I would like to hear your thoughts on that. And one question, perhaps more to the GeoBlue Planet and the AmeriGEO, if you are also working with specific stakeholders such as children or ECOPs, and if you are providing with services such as gamification on data and ocean science, and if you have special programs for ECOPs, and so that they can enter the market and have good and interesting posts. And sorry, one final, I was really interested to learn more from Charlie on that slide that you mentioned, the increase on yield from stocks, that stock biomass that we're using and applying data. I think that was such an interesting killer fact to show. And if you could provide some more info or comment more on that, that would be really interesting as well.
Would someone like to start with the science policy interface question?
Sure, I'm happy to jump in on that. So, you know, with GEO, a lot of it is focused on trying to support the science policy interface. And, you know, one thing that we've found is that it helps to have people engaged on the policy or user side, you know, from the beginning, if you're trying to develop some type of decision support tool from ocean science. And you know, to arrange that, a lot of times to get those people involved, related to your question, if we have the right people involved, you have to first educate them on what the information is and how it can be useful, and give some examples. So we've found doing kind of informational workshops with that target audience to give an overview of some of the data and science that's available, and then trying to identify specific collaborators to move forward, that works well. There also are, you know, a lot of opportunities to engage with some of the UN organizations who already have a mandate to do this, such as you know, IOC and UN Environment. So that's something we also work on as well. As far as are we doing enough? I think you know, more could always be done, and you know, needs to be done in an urgent fashion. But there does take a large amount of time for people who are trying to bring these communities together. I think that you know, there has been some pressure on the scientific community to try to include that as part of their work, but a lot of people are already maxed out. So I think trying to create more positions that support kind of the interface between the scientists and the policy, so that you know, people aren't you know, just being overloaded with what they're capable of doing in their capacity, or that they're able to focus on their specialties as well. It's something that as a community we can promote more moving forward.
Thank you, Emily. Are there other thoughts?
I'd be happy to jump in for the early career question. I'd be remiss without mentioning a core component of what we do through AmeriGEO is our Geo Pathways program. And so the intent for this program is to leverage university students and give them the opportunity to get real world analysis and skills by not only supporting our events, but our real world applications. So the Peru oil spill event, actually, we have a group of intern students that we work with not only in the United States, but also in member countries as well, such as GeoPathways Peru, Red Labat, and other student affiliation groups that are led by institutions and ministries in the region. And we work with them to develop their skills. And so they're not only helping us to engage in these larger events, but we also give them access to these systems and the programs to help respond in these real world scenarios. So in the particular example with Peru, we were not only utilizing existing government employees and organizations, but we actually utilized an entire student team to help develop that oil spill detection map and to respond to that real world scenario. In addition, we're doing various hackathons, mapathons, various different workshops and training opportunities to help bring in those early career professionals and give them the skills necessary to be active members in our community, to hopefully then transition them into a career opportunity following their university. That is also further supported by the Inter-American Academy, where we're looking to redevelop our capacity development approach from being a specific training opportunity. So not just deploying a singular training, but developing curricula in the academy so that if an individual wants to respond to, say, landslides, that they can go into the academy environment and develop a curricula or identify curricula in that academy that will give them a suite of trainings, not only instructor-led, but pre-recorded webinars, training materials that are self-paced, as well as instructor-led virtual courses. And so we partnered with Moodle and various other internet or multilateral internet providers that are looking at not only the gamification of training, but also looking at certificate programs so that when they come out of that event, that training, that they have some sort of accreditation that's coming with it.
Other thoughts? Certainly there's a lot of engagement of the ECOPs in the context of the UN Decade programs, and Charlie mentioned one of those, Supreme. I think others have come up during some of the other presentations. We're also supporting the Marine Life 2030. And there's a whole network of ECOPs supporting decade activities, and I think each of the programs have ECOPs sort of embedded within them, individuals who have a particular thematic or interest or experience. So that's an interesting opportunity. But I think a lot is being asked of those folks to support decade activities beyond the work that they're doing, in their routine jobs. But I think it's been interesting and good to see an increased focus on bringing early career professionals into activities like this, into the field work that we're doing, into some of those science policy kind of conversations. It's been fruitful, in my opinion.
I'll just add on the UN decade that with Geo Blue Planet, our European office is setting up a program called Ocean Bridges, which is aimed at supporting the early career professionals from the UN decade. And the goal of that will be to try to create cross-generational support to help with some of the networking for early career professionals. At our symposium in Ghana, this did come up as well about trying to do youth engagement beyond people who are in university. And I'll say that that's not something that GEO has really focused on in the past, but I think there's always benefit in trying to do more engagement with the youth.
I think Mauro raised his hand as well. I can see it from here.
Yeah.
Mauro, I'm so sorry. Do you mind if I interject really quickly and just ask, because I know that some people might have to jump up. Do you mind if I take the picture really fast so that we know we can capture everyone and then turn back to you? Thank you so much for your flexibility. Sorry about that. Okay, everyone. 1, 2, 3. Oh, around. Of course, I'm so sorry. Are we missing anybody else who doesn't have their camera on? I should have asked. Okay. 1, 2, 3. Done. Thank you so much.
Okay. Well, at least from the Brazilian side, I believe that we need to follow 2 avenues. The first one is to remember the Ocean Ops 2019 and to improve the engagement with the end users. I know that that's very difficult. We had a lot of trouble to engage with the end users with SiMCosta, but it's worth trying to pursue that. And the second thing, and I believe that has something to do with the COVID-19 period that we just faced. We need to re-motivate the early career students, and that's very important. So at least in Brazil, the universities are still very academic, so we have to bring these courses to the university, the hands-on courses, and train our students to handle this data with more facility. So I think that these 2 actions will help a lot to improve this engagement. Thank you.
If I may, Karen, on the first day, you made a comment that I've been thinking about ever since. We were talking about standardized data collection and sharing of data and dissemination of data. And you reflected on how the data itself is not necessarily what's useful for policy, but that what we need to do is have a conversation around co-design, around how we translate data into formats or synthesize data in ways that it actually is useful for decision making. And I would say this has been a lesson that we've learned repeatedly in MBON. And I think we're making some progress in how you facilitate the conversations with managers, decision makers, people who really have a use for information products. And I wonder if there's an opportunity to continue talking together about how we're approaching that, whether there are opportunities to do some of this together, especially in the context of our bilateral work, or in the context of some of these global initiatives that we're joined on. But I just didn't want to let that comment go, because I think it's very important, and I think we're learning a lot, especially in the context of the decade, which is emphasizing the co-design piece. And it's not natural or easy for scientists or observing practitioners to talk about.
Yeah, Charlie's raising his hand.
Yeah, no, I do have to hop off in a second, but I just thought I'd offer one more thought on that. And that I personally find the most focusing thing that one can identify with some of either the data or the models is the decision that needs to be made, right? When we think about prediction studies, I'd say for every 10 things we can predict, one is useful. and so thinking about that decision that one needs to inform, I know it was very useful for whatever success we had in the case studies that we explored, and it's really been a driving force for the CFI as we think about the management councils in the CFI's case and other stakeholders like that really provide this very firm set of needs that serves to focus both the modeling, and there aren't nearly enough OBS in CFI yet, but if we could ever get that funding, then that would be the same question. And so, but unfortunately I have to hop off, but this was an absolute pleasure, and thank you very much.
Thank you, Charlie. Great presentation. Thank you so much.
I have to leave as well. I'm so sorry.
Yeah, we have to. I just want to make a final comment. I said that in the first day, and I think one way forward is, well, in my previous life, when I was acting on the climate change policy here in Brazil, I learned that it was very useful to call on my colleagues, the policy managers from mines and energy, transport sector, and so on and so forth, into the climate change dialogue when we were discussing no regret measures. So no matter what, it's going to be cost effective to you to do a climate proof analysis and adopt a low carbon measure and so on. And that was the language that really brought them into the game back in the early days of climate change in Brazil. And I think that's probably a milestone that we should reach in the ocean science and in the policy interface dialogue. Finding these no regret measures, they bring out attention and they call on board those specialists. And perhaps for the future, I was just wondering another way to keep on this dialogue on the policy science interface, as we are two federal countries, to bring on board policy makers that deal with coastal zone management or water resource management in the state level and the federal level. And there's so much difference in the perspectives and the needs and the way to see the problem. And I can tell that from Brazil, and perhaps that should happen as well in the US. And as federation, the domestic dialogue is already so complex, and then we have to bring in science. So it's an interesting also perspective to have and share perhaps in the future. So I'll leave that to maybe a next idea that we can move on. But most importantly, I would just like to thank all of you for your time, Semi, Zoraida, and the NOAA team as a whole for being here and giving us all this great time. And for sure, now we have it all recorded on YouTube, and we know that we will have increasing views by the day. And questions and suggestions for next workshops will come. So thank you.
Thank you, Karen and MCTI, for providing the platform and making this possible. We're really grateful and appreciate the discussion and look forward to following up.
Ciao.
Okay, bye-bye.
Thank you.
Bye-bye.
Thank you, Karen. Thank you, Mauro. Thank you, everyone.
Thank
Have
you
a good
all.
weekend.